Hey everybody, welcome to Altium Academy. I'm your host, Zach Peterson, and today we're going to talk about how to design a patch antenna. Now, this is something that I brought up briefly in one of the videos in our NRF52 series, and I promised you guys a video on patch antennas, and that's exactly what we're going to talk about today. One of the things that I will present is the patch antenna design equations, and we'll go through the process for how to use them. So, let's get started. Here on the bottom layer, we have a ground plane, and then our patch antenna is going to be located just above a ground plane. We have a thickness here, we'll call it H for our dielectric, and then we have two dimensions here that we're using for the patch antenna. First dimension is, of course, the width, and then if you look at this from the top view, we will have our antenna. We generally have a feed line coming in, and then we'll have a length right here. Your job as a designer is to basically determine what the width and length are for your patch antenna, given a value for H, and then given a value for DK for your PCB laminate material. So generally when you're designing a patch antenna, these are the two things that you get to choose. You get to choose them because you get to design the stack up. Then of course, but this is a very and design your feed line coming into the impedance match just inverted. And then we have a factor that relates
Beamforming is a signal process. To begin, let's and antenna control technique that allows us to steer the direction of maximum radiation or reception without physically moving the antenna. It's like replacing a light bulb with a flashlight. You still use the same energy, but now it's focused in one direction, giving stronger illumination where you need it. Beamforming works because multiple antennas, or antenna elements, transmit signals with carefully adjusted phases and amplitudes. The waves combine in space, adding up constructively in some directions, producing strong radiation and cancelling out in others, reducing unwanted energy. This constructive and destructive interference shapes and steers the radiation pattern, forming the beam. Consider a linear array of antennas spaced evenly at a distance, d. When all antennas transmit the same signal simultaneously, the strongest radiation occurs perpendicular to the array, called the broadside direction. If we introduce a small phase difference, known as a progressive phase shift, then we can change the main beam's direction. By slightly delaying or advancing each antenna's signal, we can electronically steer the beam toward any desired direction. For example, in this case beam is steered by an angle of 30 degrees. And in the same way, by varying the phase of signals feeding to antenna elements, we can steer the beam on the other direction. Imagine a single antenna element. When it transmits a signal, it radiates energy in almost all directions, just like a light bulb spreading light everywhere. Now, if we increase the number of antenna elements to 4, the radiation pattern changes and becomes more directional. If we continue increasing the number of elements to 16, and then to 64, the main beam becomes even more focused. This is the essence of beamforming. By using multiple antennas and controlling their signals, we can concentrate the transmitted energy in a specific direction. Beamforming is widely used in modern wireless systems. In Wi-Fi and 5G, it directs signals toward users for stronger coverage, higher speeds, and better capacity. In radar, it enables fast electronic target tracking, while in satellite communications it creates focused spot beams for higher efficiency. Even Starlink uses phased array beamforming to track LEO satellites and deliver high-speed internet worldwide. from World War II radar to today's 5G and future 6G.
Start with a single antenna is beneficial. With phased arrays, the beam steering is done electronically, so not only does this mean that there are no moving parts, but we can steer the beam to a new target in a fraction of a second. And not just this, but phased arrays can also be used to generate multiple beams, each that are steered independently from the other. And this is all done using a single array. So, with that being said, let's look at how we can actually form a narrow beam with an antenna array, and how we can steer that beam through phase shifting. Let's go back to our single isotropic antenna, and we'll just look at half of the pattern. The antenna is radiating out a sine wave, where the dark lines are where the signal is high, and the light lines are where the signal is low. Now, this antenna has no directivity since it radiates equally in all directions. But imagine we have a second antenna that is placed half a wavelength away, that is also radiating out the exact same sine wave. Now, I know that this is a bit hard to see like this, but I want to explain a few parts of this image because it's important for understanding how the array works. Along the horizontal axis, we can see that the two waves are exactly out of phase with each other, since the light part of one overlaps with the dark part of the other. This means that when one signal is high, the other is low. And when we combine those two signals, they cancel out, and we're left with very little energy in these directions. However, if we look up in this direction, we can see that the two signals are almost perfectly in phase with each other. The light lines up with the light, and the dark with the dark. This means that both signals are high or low at the same time, and they constructively add in that direction. This means that the interference pattern that results from these two antennas looks something like this. In this image, the dark areas are where the signal is canceled, out off to the side, and the colored portion is where the signal is stronger. So we can see that even with just two antennas, we already have a more directional beam than we did with a single antenna. Now, this isn't a very sharp beam, and we can see that a little more clearly if I zoom out a little bit. So if we want a sharper beam, we need to increase the aperture of the antenna, or the width of the array. And one way to do that is by simply moving these two antennas apart. Notice how the main beam gets narrower as I move the two antennas from half a wavelength apart out to 1.5 wavelengths. However, this has created some additional unwanted effects, like these two grating lobes. A grating lobe has a gain that is comparable to the main lobe, which can cause some trouble determining which beam a detection is coming from. So, instead of spreading out the antenna elements, we can increase aperture by adding more antenna elements, each at a spacing of half a wavelength. With 3 antennas, notice the main beam is narrower. But we also have 2 weaker side lobes that appear. Again, they're not grating lobes since they are much lower gain than the main lobe. Alright, let's add more. Here is 4 elements, and the main beam is even more narrow. Here is 6 elements, and then 8 elements. Each time, the beam gets narrower and we get more weak side lobes. Now, look at this beam. It's like a spotlight shining up into the sky. And what's kind of amazing about this is that all we've done is line up 8 isotropic antennas in a linear array, and the interference pattern between them results in this really directed central beam. And that's pretty cool. Okay, so that is the basic principle behind how an array of antennas can create a directed beam. It is just the pattern that is created from the constructive and destructive interference between the different antenna elements. And as you pattern. But I think the gain and azimuth plot to an 8 by 8 element rectangle 10 degrees, and to do that I created a script that loops through and changes the steering angle from -90 degrees to +90 degrees.
And that's pretty much it for this simple Python script, but I hope it was helpful to see how the phaser was controlled and how that data was processed. Okay, so that's it for this basic introductory video. It went maybe a little bit longer than I had wanted it to. In the next video, we'll start to look at a little more interesting things. We're going to explore all 8 elements now, and here's the configuration. So in this diagram, I have 32 antenna elements, and let's just say that each row of 4 gets some interesting demos, but I want to go through this slowly and step by step so that everything is clear by the time that we get to those cooler videos. Next, radar is a very high growth area for these phased array antennas. A traditional radar system uses a mechanically steered narrow beam, just like what we saw on the previous slide, and that provides selective coverage. But phased array radars use electronically variable phase shifters that permit fast scanning or the ability to track multiple targets while simultaneously carrying out a search for new targets. And then the third primary area of growth is in satellite communications. Many low Earth orbit or LEO satellite constellations are being launched. Think of things like Starlink or Amazon Kuiper, and also a variety, while signals at other angles experience destructive interference. So you get a signal from the direction you want, and all other directions get attenuated. It's going to strike the next element. And then some very small amount of time later, it's going to strike the element after that, and so on, until this RF wavefront has shined across the entire face of the array. That animation and rotated a bit, we can see that that wavefront formed the hypotenuse in a simple triangle with the array of elements. There's a few key terms that are good to define right now. So this term D is the distance between elements measured center to center. Theta is the angle. We could describe that delay as a phase shift, but that phase shift is really just the time delay at one particular frequency. So if our frequency changes, our phase shift needs to change in order to keep the time delay the same. But for narrow bandwidths, mechanical bore sight, and our frequency is 10.4 gigahertz, and the element-to-element spacing is 14 millimeters. So if we plug those numbers into that equation, we find that we would need an 87-degree phase shift from element to element. Those blocks are combined together in what we call the 80 ALM phaser. It consists of Pluto, which is a simple software-defined radio, a Raspberry Pi to control and collect data, and finally the actual phaser board itself, which integrates the RF circuitry with an 8-element phased array antenna. The setup is all open source. The schematics is a radio chip from the 809361 transceiver family. Now, by default, Pluto has one receiver in the range of it, and we just input Atlanta. I had this HB100 slide. Examples can be found on our wiki.analog.com/phaser site. And then finally, we grab a buffer of data from it, and then of course we can process or plot that. Now, let me walk you through. You could control Pluto or any IAO object remotely solely over the Ethernet address. So this kind of simplifies some of the connections and allows me to control Pluto over the same Ethernet port that I'm also talking to the Raspberry Pi on. But like I said, it is a little bit slower than if I would just plug Pluto into the computer and use this IP address. Then the only other thing we want to set is what steering angle that we want to take the FFTs at. So it could just be one steering angle, or if you put in a list of steering angles or an array of steering angles, then it will step through each one of them. It pauses a couple of seconds, plots it, and then goes to the next steering angle. So if you kind of want to sweep the beam like what we were doing on the GUI, you could use something like this. Frequency one in the program went both of them. Next, this is just a simple function here to convert our raw IQ samples of data into dBFS. That's decibels full scale. We sum them together, and then we compute the decibel full scale of that IQ data. And then we just plot
This watch is 3D printed, and so is this one, and they're both printed with 3DX Tech materials. I've been into watches long before joining 3DX Tech, but when I realized that you could 3D print your own watch, I knew I had to try it for myself. Both of these watches were designed by James at theprintable.watch.com and printed out of 3DX Tech materials. But I want to focus on the Moon Phase watch. It uses a Miyota 6P24 movement and off-the-shelf hands, but everything else in this watch is 3D printed. For this build, I used 3DX Max ASA for the bezel, dial, chapter ring, case back, and even the tiny little stem. The main case is printed in our Carbon X carbon fiber filled ASA for added stiffness and dimensional stability. I chose ASA for its UV resistance, mechanical strength that's
This is wild. It's so strong that it hurts. Yeah, see my thumbs?
Today, we're going to be taking a deep dive into one of the most advanced 3D printing materials on the market, carbon fiber reinforced polyether ether ketone, or CFP. This is a high-performance thermoplastic composite known for its incredible strength, thermal resistance, and chemical durability, making it a top choice for industries that demand the best. So what exactly is CFP? CFP is a composite material made from polyether ether ketone, a high-performance polymer reinforced with carbon fibers. These fibers can be short or chopped, typically making up to 10 to 30% of the material by weight. This combination results in a material that offers outstanding mechanical, thermal, and chemical properties. CFP is part of the PAEK family of polymers, known for their excellent stability in extreme conditions. By adding a carbon fiber, you get a material that's not just strong, it's exceptionally stiff, lightweight, and resistant to heat and wear. Now, let's break down the technical specifications of CFP and what makes it such an impressive material. Tensile strength. CFP is used in some of the most...
Here we go. Ooh, yeah. Yep, bouncy. Definitely good. All around. You can hear that. You make music. Oh, and I got a break. All right, guys, today we're talking about Carbon X CFPC from 3DX Tech. Now, this is carbon fiber reinforced polycarbonate filament, known as CFPC, and it's a fantastic printing material with great strength at higher temperatures, really nice surface finish, and it's relatively easy to print. Now, PC is often referred to as Lexan, polycarbonate, Macrolon, and it's really a popular material that comes in a lot of different forms. The 3D printing filament, it can be really good for high heat applications requiring a lot of fine detail and strength, and with the carbon fiber, it's even better. This filament is ideal if you want to make a structural component that resists high temperatures, really stiff components, and something that still has great surface quality and good dimensional stability thanks to that carbon fiber. So here's the box that you get when you buy it on visionminer.com/materials. We've got this stuff in stock all day long, and it comes right here on a spool like this. Now you'll notice this particular spool is not vacuum sealed, but that's okay because you have to dry this before you print it the first time anyway. It is really nice thick material, but it doesn't always come fully vacuum sealed. Don't worry about it, it's not an issue. You can dry this and then use it regardless of if it's, you're gonna have to dry it. Dude, well, it definitely dripped. Very similar to polycarbonate, definitely lights on fire and stays on fire. Definitely not something you want exposed to open flame, especially if you're worried about burning the house down. Don't do that. Okay, so let's move right along into the thicker material. So that was a very, very thin piece. This is a thicker material, and it's actually, let's see how it... And about 10 seconds. All right, so you can see it started to shrivel up a little bit and shrink up. Seconds. Let's see if we can get it to burn on fire much. Kind of with the HTN CF25 from the Centium, it sort of bubbled out as opposed to melting off.
that unless we evolve
citizen, my
ideas, let's start there. Who is
me, it occurred, what if it doesn't just apply between the Planck scale and the cosmic scale, but everything in between? So I chose for the energy gradient, which it's a very simple.
Oh, we're and what have you. And then he doing lately is that
necessary for arcing. So you want to try to keep your voltage below the. Now, all right, this is let me just go into this quote unquote extended electrodynamics engineering, the engineering of rather exotic physical phenomena. One thing that I've noticed that they always tap, even Kurt Jaimungal brought that up. But Sal, it's so hard to get that 1 coulomb of electrical charge. It's not possible, really. Remember what electrical charge is all about. It's capacitance times voltage. Now, it is true that the capacitance of quote unquote usual, ordinary objects is quite low, extremely low, driving the voltage to get that 1 coulomb of charge extremely high, way past the 1.3 times 10 to the 6 volts that's necessary for arcing. So you want to try to keep your voltage below the 10 to the 6, the 1 million volts that will result in arcing and thus loss of charge. How do you do that? Well, there's another way. This is where engineering comes in. The whole idea is that you use, say, electrodeposition of nickel metal alloys that can have, say, 4,000 farads per gram possibility. So 1 kilogram of matter would give you what? The 4 million to counteract that million voltage you're not looking for in order for not to lose the charge. So again, it is always possible, gentlemen. Nothing is impossible. It is all based on conditional possibilities. The trick is to find under what conditions, or in this thing, you manufacture a metal that yields that extremely high capacitance to counteract the voltage at which the physical object will not hold a charge, it will arc. This is all engineering. This is what it's all about. There's no such thing as impossible engineering. If you put your mind to it, if you truly believe that something is possible, it becomes possible. Somehow the superintelligence dictates it into being. Physics, gentlemen, is not something that is hard.
And that's Lawrence.
This is it. It's written on graphite with this chisel, and thou shalt not ever change it. These are the commandments of physics.
And that's Lawrence to mention my technical background.
Never changing. Bullshit. Physics changes according to the superintelligence and whatever that superintelligence dictates. So, sorry that I went on a diatribe over there, but I thought it's important to bring up how can you get that 1 coulomb of electrical charge? Yes, you can. You manufacture a material, electrodeposition of layers. How interesting that layers would be used. But anyway, 4,000 farads per gram, certain nickel cobalt alloys, metal alloys, metal oxides, as a matter of fact, have that capability. 4,000 farads per gram. Doesn't take a freaking, let's say, quantum physicist to realize 4,000 farads per gram, 1 kilogram object, 4 million, counteracts that million voltage that would make the object arc. So yes, that object can have a 1 coulomb of charge on its surface without arcing. There you go.
Could it be possible that, Sal, question for you, could it be possible that through the use of what Ken Shoulders called exotic vacuum objects interacting with certain types of materials, you can achieve the 1 coulomb static charge?
course, that's another way.
Right.
What I'm saying is that there are no impossibilities. You
Right,
can
right,
always
right.
engineer this thing, but you have to have that objective in mind, and you have
Yeah.
to again, do away with the box. Forget the fucking box. This is
Right.
not about the box. You engineer the box away, and
Right.
everything is an open system. Things talk to
Yeah.
one another if you know how.
Right.
Yes, but how do we get 1 coulomb of charge on without arcing? Just kidding. Was this related to your patent on producing the microwave like cavity around the craft? Is it that's from the hybrid undersea inertial mass reduction patent, I think?
Could be, but this is more related to something Kurt Jaimangal said at one point in time, and he's a trained physicist, that
Yeah,
it
but
is
isn't the idea
extremely
though is that you
difficult
want
to get that 1 coulomb of charge.
the idea is that we're trying to make a plasma sheath or something kind of bubble in any of these situations, even in
Brother,
I think,
you hit on the physicality which you need. It's plasma. That's what the key is. And why plasma? Because it is a non-linear physical medium that also has the ability to be driven far from equilibrium. That's engineering the Prigogine effect. That's what the Pais effect is all about. And that's why your
I'd
orbs...
ask Lawrence to mention my technical background. Those who know me well. But you know that's what people know. Those waves have funny things, though. I'll mention that. They're massless. Well, I guess they don't exist. They don't have any mass. There we go. They're polarized, i.e. they have electromagnetic direction. Oh, and they're affected by gravity. So they're a massless thing that's polarized electromagnetically and affected by gravity. If you really think hard about that, right. It's like, if it was in literature, you can't have those three things in the same sentence. Sorry. So they're photons. And what's a photon? Well, it's a particle and a wave. It's neither a particle or a wave. Vince is smiling. He knows that's the way it is. So when I was first reading cosmology, I understand all that. I said, no, I don't understand quantum physics either, but that's okay. Yeah. Esoterically, it is what is hidden behind that outer garment. Well, there's some really tough questions in here. Let's look at that word enlightenment. The achieving clarity of perception, reason, and knowledge. That's exactly out of Webster's. I'm not leave to give you a dark set of said it proposed a somehow. In space and time, it's as if all quanta, all things, all systems, all information exist everywhere simultaneously. That's what the physics gets us to. Whew. And then we have, well, maybe it's a 3D hologram. But now there's new terms to get rid of ether. Some call it the cosmic plenum. I love the middle one. It's the new ether. New using the Greek term for new. I don't know how that got by the publisher in the journal Science. I really don't. But that's a technical term now, the new ether. It's not like the old ether theory, it's the new ether theory. Some call it the matrix. You like the next one? It's the fractional quantum Hall state. There'll be a quiz tonight to tell me what that means. The next one is the fractional quantum Hall state. There'll be a quiz tonight.
So how exactly do you build a quantum liquid out of fractional electrons? I mean, it sounds kind of like science fiction, right? Or maybe a bizarre riddle. But honestly, it's actually one of the ultimate holy grails of modern quantum physics. And we are getting incredibly close to solving it. Welcome to this explainer. I'm literally so thrilled you're tuning in today because we're looking at an absolute game changer in quantum simulation. We're going to unpack a super fascinating paper from researchers at Beijing and Zhejiang universities. And they haven't just, proposed some abstract theory. They've actually mapped out exactly how to prepare a highly exotic phase of matter, the fractional quantum Hall state, on the noisy, imperfect quantum computers we have today. It's a brilliant piece of work, and the way they've structured their solutions is just incredibly elegant. So, to understand how they pulled this off, we're going to follow a really clear 5-step roadmap today. 1. The quantum Hall mystery. 2. The simulation challenge. 3. 3 paths to preparation. 4. Surviving quantum noise. And 5. Proof of topological order. All right, let's just dive right in. Section 1. The quantum Hall mystery. Okay, before we talk about the how, we really need to nail down the what. A fractional quantum Hall, or FQH state, is basically this highly exotic quantum liquid. Think of it like a bizarre 2D puddle, where the particles interact with each other so intensely that they literally forget their individual electrons. Instead, they collectively act as if they have fractional charges, showing what we call long-range entanglement. Actually, scratch that. It's more like a completely different paradigm of matter altogether, one that relies on global topological properties instead of just local order. And here's the kicker. If we can master these states, we practically unlock the door to fault-tolerant quantum computing, using exotic particles that remember their past movements, called non-abelian anyons. It is absolutely huge. Moving right along to Section 2, the simulation challenge. Now, you might be wondering, don't these states already exist in nature? And yeah, they do. We've seen them in extremely cold, 2D electron gases placed under massive magnetic fields. But simulating them accurately on a quantum computer, that has been a notorious mystery. Why is it so hard? Well, because strong interactions just don't have simple parent formulas that we can easily program. In the past, researchers kind of cheated. They simulated these states using a 1D approximation called the thin cylinder limit. In that quasi-1D space, the interactions are a lot simpler. They just follow local squeezing rules. But you completely lose the true magic of the 2D topological order. But this new method, it totally abandons the cylinder and maps the target state onto a spherical geometry. By putting this quantum liquid on the surface of a 3D sphere, you get no edge effects and the whole space is completely isotropic. So it captures the genuine, complex, non-local squeezing of a true 2D fractional quantum liquid. Mathematically, it's a beast, but it is far, far more accurate. Which brings us to Section 3, 3 paths to preparation. So how on earth do we actually program this pristine spherical state into a real physical quantum computer? Well, the researchers tackled this by giving us not just 1, but 3 distinct preparation techniques. They designed an exact digital circuit, a variational quantum circuit, and an analog optimal control method. And each one has its own distinct vibe and application depending on the exact hardware you've got. Let's take a look at that first path. For a 7-qubit FQH state on a sphere, you'd probably expect to need this massive, convoluted mess of logic gates, right? But by exploiting the extreme sparsity of the FQH wave function, they distill the entire preparation down to just 12 single qubit gates and 14 CNOT gates. Literally, that's it. Even if you aren't super deep into the math, you can totally appreciate how incredibly lean this circuit is. It operates sequentially, just going qubit by qubit without even needing any extra ancillary qubits. Then we have the second method, the variational quantum circuit, or VQC. This approach is kind of more like a machine learning algorithm. You set up a parameterized circuit, and you basically train it to find your target state. And as you add more layers, which gives the circuit more expressibility, the fidelity just climbs. With just 4 layers, you're hitting nearly 98% fidelity in quantum. Here, we're moving away from neat, discrete digital logic gates and jumping straight into the wild realm of analog physics. We're talking about the actual continuous microwave pulses used to directly drive a superconducting quantum processor. Instead of a step-by-step circuit, the system is just bathed in these chaotic, beautifully continuous electromagnetic waveforms, and they steer the quantum state straight to the target in mere fractions of a microsecond. All right, section 4, surviving quantum noise. Because, look, it's all well and good to have perfect math on a whiteboard, right? But today's quantum computers are noisy. They make mistakes constantly. The exact error runs out 32% fidelity. But Rydberg atom platforms actually capture the magic? Like, is it a true fractional quantum, the realistic, the incompressible, repulsive spatial correlations of a genuine fractional quantum liquid? The electrons avoid each other exactly the way they are supposed to. Literally every diagnostic test confirms that these circuits and waveforms successfully summon this exotic phase of matter. So we've seen how these researchers bypass those old 1D cylinder.
Hi everyone. So tight that they're
You like the next one? It's the fractional quantum Hall state. There'll be a quiz tonight to tell me what that means. No? Okay. Or it's string nets. Everything's connected together in these minuscule strings that go for infinity, who have a total diameter of 0, in essence, and they connect everything. I don't know if you know what the amplitude-hedro theory is. The Japanese proposed about 2 years ago, we can solve this mathematically if we get rid of these 3 dimensions and say there's 12 dimensions, and then I mount everything on those, and that's where the amplitude energy mass. What does it say today? This is quantum everywhere. There's vacuum fluctuations. It has to and tell me if there's a difference. But the lower one has a lot of math on it. There's emerging concepts, and everything. Everything is in touch throughout the cosmos, all times and places. When there's such is interconnected from just articles in the last few months. The quantum vacuum energy exists everywhere. There's vacuum fluctuations. It has a central role. It affects large-scale phenomena, and the zero-point field where there's absolutely nothing does in fact exist. Now, you can connect that to the upper one and tell me if there's a difference. But the lower one has a lot of math on it. There's emerging concepts, and everything is in touch throughout the cosmos, all times and places. And there's some underlying structure we don't get, and shockingly, the vacuum is subject to influence by consciousness and intention. Anybody want to give up yet? Okay, just thought I'd give you the offer. That begs the question, because it always comes back to that. What's electricity? Well, I'm going to give a ditty with a nod to Dr. Seuss. It's like asking Mrs. Cave, who is Dave? You know that one? Yeah. Did I ever tell you that Mrs. McCabe had 23 sons? And she named them all Dave. There they are. How can she describe her son? That's a hard question. When we called for her son, they all came running. You know, with your kids, come on in. Jesus, did she mean Jack, Jill, Dave? So Dave comes in. Poor Mrs. McKay, right? We assumed there was only one. Yet she has many sons, all named Dave. Now that's silly, right? You ever look at electricity? Well, we're going to. If we look at a standard textbook, it's a physical phenomena of the presence and motion of electric charge. There will be a quiz tonight. You can tell me what electric charge is. It's electrons and protons. It's part of a single phenomena called electromagnetism. I'm sure most of you know, if you have an electromagnetic field, you're going to have electric charge and you're going to have. I'm going down this path. Electricity is often used as a single name. Now, why am I going down this path? If you've read some of Cosmic Fire, how many times is the word electricity in that book? It's more than hundreds and hundreds. And how many times in that book, if you really studied it and studied the others, does it seem like he or she is making a different definition of electricity every time? That's the first impression I had. I'm going to give this book up. You can't keep your definition straight. Who the heck are you? Well, what do we do about that? Here's some Daves. There are a lot of Daves. We call them electric charge, right? We call them electric energy. We call it electric current. We call it electrical science, electric field, electric power. Oh, and we can even call them sparks and waves, down there, voltage at the bottom. They're all manifestations of electricity. The day I realized that, I went, oh, no wonder DK says it's electricity, it's like that. What else is he supposed to say? They're just different manifestations of some underlying thing we don't fully get. Which one? When somebody goes somewhere else. There's a number of science that gravity is a polarizable vacuum. Faster than people realize, but
are 100% real, and F anybody who believes otherwise.
Well, there's condensate too, right? We just can't.
Or Prigozhin need to be driven far from equilibrium. That's why you're hearing the Prigozhin effect. That's what the Pais effect is all about. And that's why your orbs are 100% real, and F anybody who believes otherwise.
Well, there's condensate too, right? We just can't see it on the film. Or am I mistaken? That's like what the trailing is, or?
Oh, you mean the Bose-Einstein condensate?
Yeah. Like I don't know if it would be visible or not to the naked eye, but there's probably like an energy trail from it, I would assume, right?
Macroscopic quantum coherence.
The quantum.
One could say that's becoming more true than people realize. An example is the electrical human body, which we now know is deeply related to the state of the body. And everything in us has electric charge, don't they? Sodium, potassium, calcium, magnesium. What's your body made of? Mostly water, and the rest of it are these kinds of elements. almost all cells are charged elements. We call them ions. Ions just means it's missing a plus or a minus, and so it's electrical. So they generate electricity. The old story, your body electric, is probably true. There are even cells specialized to conduct electrical currents, has been discovered. And now the proposal is your muscles actually have two jobs. One of them is to pick up my water glass and pull it. The other one is that your muscles are actually batteries, and it's storing the energy in your own battery, own muscles. And if you think of that, then the whole body is an electromagnetic system. And it's very much conforming to what many people see. And that healing is voltage. There are proposed work now by doctors in the field who are curing cancer by simply changing the electrical dipole of a certain muscle. To be happy. Well, pharmaceutical companies are not going to be happy with that. I'll go back one, as there's not all showing. You can look some references on this on Wikipedia, of all things. Boy, it's really in trouble when it's getting on Wikipedia. That healing is voltage, Dr. Jerry Tennant references that to the. Let's see, did I miss one? No, I'm going to see if I can go back. Yeah. Bioelectricity shapes anatomy. Now, there is a proposal. What choreographs billions of cells to create the intricate anatomical patterns of your body? Well, it's genes. But the latest research is that it isn't. But what shapes your body is electricity and electricity only. And the genes are nothing more or less, and yet, a list of materials to be put together in the building of the body. They're not the blueprint. The blueprint comes from the electromagnetic field that comes from, well, that's not a discussion we should probably have, right? We also know that there are some animals that lose their head and their tail and then grow new ones, lose their foot and then grow a new one. People can't do that. You can if you put an electrical field on it, as the Japanese and Russians are showing. Well, that's not too good for the surgical industry. Disruption is coming. Now, this is by some really weird people, right? They're all wackos. Notice the research institutions in the world that are working on this theory and proving it in the laboratories of medicine. Tufts University, University of California, Merced, California Davis, California Dennett, Institute of Molecular Biology in Vienna, Austria. The Smithsonian's support of the Tropical Research Institute in Costa Rica, where they have so many promises, physical promises. I didn't put in all the Russian institutions because they got another half a dozen. The science and medical people in the world are thinking this very differently. At the bottom is a little thing you can't read. Grow with the flow. How electricity kicks life into shape, which is a summary of some of this recent work. Well, what's the body? What are we? This physical part. You know it always wears out. So, yeah, most of us are old enough to know some of that. Injuries, infections, right? You ever thought about how fast your body changes? The macula of the eye is completely replaced every 48 hours. For every one of you in the room. Kind of summary. And what's the relationship between matter and this funny thing, soul? Well, these discoveries unite matter and electrical, but there's enough doctors looking. So let's get to where this kind of summarizes. What's the science concept of the garment of God? It's sure looking like that one, that everything is essentially electrical, positive and negative. There is a garment. And what's the relationship between matter and this funny thing, soul? Well, these discoveries unite matter, energy, and consciousness, as if everything is connected to everything else, and the law of attraction, love, holds all together. Does that sound familiar in some books you read? Love. If everything is unite matter, and what's the relationship between matter and this funny thing, soul? Well, these discoveries unite matter, energy, and consciousness, as if everything is connected to everything else, and the law of attraction, love, holds all together. Does that sound familiar in some books you read? Okay. Here's the fun part. That's exactly what quantum mechanics says. Everything is connected. You betcha. And we'll show a little bit on that. Non-local interconnections transcend separation. Chinese are doing that. We're doing that. Chinese recently put the new vehicle up in space. They have the two clocks. They matched them on the ground. They launched one into space. I moved the one on the ground. That one moves at exactly the same time. Okay, it's on the other side of the planet. It's 60,000 miles apart, and the instantaneous transfer is 0 time. Well, that's a bit of a problem for some theories. It's not a metaphor. It's shown. The electron is now proposed to be aware of the rest of the universe and responding to the large environment at all the time. This is where science is having to push itself. The systems of electrons, you can entangle electrons and protons as a system. Photons, I mean. Oddly, if you have multiple groups of them and you move them all over the planet or put them on the moon or whatever, if you change the state of one, it determines exactly the state in the other, and the time lag is 0. So there's some fundamental interconnection between matter and consciousness that's not depending on time and space. Now, that's all fun science, but science is studying consciousness. They're getting together with the medicine, which is because of it's related but exists in culture, and you're asking the question, well, what's spirit, what's soul? That's pretty weird. Science, of course, as Bauer put, is this human pursuit. Deeply personal. Many of you know scientists, some of you have been one, even those of us who kind of moved away from it. It's really you, right? It just becomes you. It's often flawed, as she pointed out, but it's often groundbreaking, really changing the world. So let's look at that funny thing, consciousness. In esotericism, it's defined as the innate in each individualized state a capacity for relationships with all other states of being objected to itself. That's DK's writing in Cosmic in Treatise on White Magic. The consciousness is primal and everything is conscious. Now science, as I said, right to say that epiphenomena of the brain, and the form is primal. But today, you can read the research articles, no. It's actually an manifestation of consciousness. That's some brave people. So, epiphenomena of the brain, and the form is primal. But today, you can read the research articles, no. It's actually a manifestation of consciousness. That's some brave people. So what do the philosophers say? Dr. Thomas Nagel recently wrote in his major book, materialist conception of nature is almost certainly false. Dr. David Chalmers up there, some kind of consciousness pervades the state of the universe. I can't imagine when I was studying quantum mechanics anybody writing that. But today that's what they write. Well, biologists. Dr. Stuart Kaufman is one of the major leaders in that field. Darwinian theory must explain complex, intelligent creatures' emergence. Has never been able to do that. Where did they come from? One. The work says
objects that show quantum properties, and therefore we always imagine they should be at this low temperature. The thing that I was investigating related to them is, well, can we get them at a much higher temperature?
Room temperature.
Room temperature, for example?
Magnification weapon. It was actually presented at one of the invention evaluation board that I held on the plasma compression fusion device. The plasma compression fusion device can be modified under certain condition. Let's call it Z-pinch with a fusion twist. I know it sounds like a cocktail, but trust me, this is a cocktail of absolute death. And it is the ultimate freaking weapon of space-time modification. The plasma disruption fusion device can give an energy yield on the order of I squared B cubed, on the order of I squared B cubed. Now, that I and B is standard nomenclature. Current in a certain fashion, and B is the magnetic flux density. You do the math, you see what sort of energy fields or rather yields we're talking about. Something that would make a quote unquote thermonuclear, say a standard tele-Ulam device be more like a firecracker in comparison.
Well, is there another reason why they're hiding it? Like, because you could also flip that to maybe heal everything on the planet to live like a billion years, like, or whatever.
It is so much easier to destroy than to create, brother. And this is their philosophy. Unfortunately, this is the philosophy that drives these quote unquote nefarious minds. You see, we must unite and fight. Again, unite and fight against the dying of the light. The light of humanity, brother, is in peril. It is in jeopardy. Unite and fight against the dying of the light. If I have one message in today's pod, that is it.
Very well
So what
said.
do you think, Dave? Do you think Hal's in the
Hello, children. Let's read the given question. The question says, Lorentz force can be calculated.
Him in your own papers.
Yes, I'm as much a liar as he lies.
Here, Forbes, you have to pick somebody in this earth. Who do you think sent it to you?
Rotating in a different direction on the top versus the bottom, so on and so forth. So I what I'm trying to say here, without going into the maybe the boring details for some in the audience, this is from 1982, and it's there possibility for breakthroughs, but then you never hear anything after.
Do they speak of plasma, brother? Do they speak of plasma in here?
They
got
in
a
one of
million things.
Are key to this whole effect.
Right. So thank you for the so thank you for letting me share. And yeah, there's 19 academics today.
But this was a Manhattan-like project, most likely, that went on, that cracked it. And they cracked it, and then they gave it to the corporate world. Why? Lack of FOIA, lack of visibility.
I saw something I want to mention very quickly to your point, Sal and Ashton. There was an article that was posted probably, I don't know, 2-3 weeks ago now. It was very interesting, the case they were making about that.
Well, because that particular effect speaks to macroscopic quantum coherence.
Right.
And the engineering thereof. This is key.
Right.
For the first time, they cracked the engineering. Remember the idea of Dr. Joseph Farrell is not enough to talk about the physics of Gabriel Krohn. It's the idea of bringing in the engineering of electrodynamics under far from equilibrium conditions.
Yep, I got you. Because it looks like even in Gabriel Krohn's papers, he was very controlled as to what he could publish. So you notice he mentions
almost impossible to get his books now.
Yes, yeah. And it's funny because he mentions back in the 40s that he was working at the time for General Electric and the Navy on network analyzers, and he was claiming that in his papers, there's no such thing as negative resistance yet, but There are a couple that exist on current Navy network analyzers. So he just contradicted himself. What that tells me is that he was being controlled as to what he could say or not say in his papers, and somehow he slipped that one through. So, in other words, he was trying to say, because the idea is that if you can get the quantum vacuum to behave as a negative resistor, then you essentially have an over unity free energy COP over one device. It's just a constant pump from like a heat pump from the quantum domain, as you were saying, Ashton. It's just a constant, just keep pumping it, pulse, etc. And so
Try to
Gabriel,
patent that, brother. See what happens.
yeah, and
Ask
so
Deborah Chung. That's why
right,
immediately I realized negative resistance has to be so significant. If you just look at the math, you're like, wait, negative resistance shouldn't be able to exist because if it
yes,
does, then like we can just cheat the math here and like get free energy. So that's the big thing and why it's so controversial.
right,
Let
yes,
me add here because John Archibald Wheeler, famous quote said, "Space-time tells matter how to move, matter tells space-time how to curve."
had a curve, yeah.
If you think about that, that's really implies there's an extra dimension. Why is it that I and other people that are ether theory theorists, why are we always saying using that quote and that reference? Because it was Einstein that realized that yes,
Push 2 and clear this trench system out.
Personality has changed in its specificity, in its speed, in its reach, and ultimately, I think, in its costs.
If we can go back to this convergence that you mentioned earlier, I like this.
And differ in ways that allow them to be somewhat more permissive, perhaps more promiscuous in what it is they can actually do on the global stage. And then how do we maintain It's a winding road through every logical, the psychological, and the social, or kinetically, or some combination of both. It can be engaged, overt, clandestine, or overtly targeted. This is an area of much of my work over the past 20 to 25 years, and part of that has engaged the development of approaches of drugs, bugs, toxins, and devices that could be used, duly used, not only. Many of the effects tend to be somewhat subtle, but many of the effects are very overt, very profound. The health incident department is the Havana syndrome, and I've had the great privilege and honor of working with my Department of Defense and Department of War colleagues on the Havana syndrome and the health incidences and occurrences that have been induced in these individuals who are suspected to these forms of directable energy. And we recognize that these types of energetics are highly weaponizable. Many of the effects tend to be somewhat subtle, but many of the effects are very overt, very profound, highly disruptive, and in some cases destructive. Next slide. We also have to appreciate that the contemporary palette of neuroscientific and neurotechnological capabilities that can be duly used, duly apprehended, and therefore engaged as part of the battle space, the cognitive and neurocognitive battle space, are highly reliant upon data. As my colleague Diane Diulis and I have noted in the international individual and groups assessment, subtle imaging, iconographies of electromagnetic or even sonic forms.
Killing it on the subject of our country's current political travails. She also happens to be the executive producer of Roseanne Barr is America, which streams on Apple.
Future was planned even before Hitler surrendered. And that's what I found most disturbing is it appears to me that we were all told that Switzerland was neutral, but it appears that what was really happening in Switzerland during the war was a group of Wall Street lawyers and international bankers were figuring out how to move Wall Street lawyer slash banker companies that we still know today that really were preserving, as they said, at this particular
Office in D.C.
Right, but it's completely protected because Switzerland has no jurisdiction over the Bank of International Settlements either, and it's purposefully secret out how to restructure Germany, and instead, what they figured out was that now that America, according to these men, was the main world power, that they would have to have some kind of operation that would exert soft power, which is really influence over elections, over population, color revolution tactics, and Truman signed it. Essentially a totalitarian slash socialism movement playbook on us. Because if you in front of, I guess, Congress or something, international news, met in, Bliss Brothers walked into the systematic racism and all of, Obama was born into
What does Donald Trump represent? And
my heart
down
matter commission, that Olshan Lab in California.
For academic pursuit. But if you go back and ask the question, why is because we still have in this the
known in phase conjugation in optics.
Field equation. Why is Planck's force there? And it says it is Planck's force, the superforce, acting on the spatial temporal geometric structure locally that generates what? Energy density, hence matter. Why? What is the Higgs field, brothers? All right, Ash, go ahead, sir. Soon
Let me
locally It generates what? Energy density, hence matter. Why? What? Is the Higgs field, brothers? All right, Ash, go ahead, sir. Soon I have to drop off. I don't have a choice. Go ahead.
Let me try to answer that.
Has been attempted to sort of be, I want to access to. For example,
You're fucked.
Sorry, I'm not laughing at. I would rather listen to you, Sal.
It's so hard. He's never seen a star in the shape of a donut. Remember that great man that once said, a house divided cannot stand. A house divided cannot stand. Imagine the strength. Imagine the power of this nation if we were united. Unification. We have to somehow become united. Enough with this polarized nonsense. Enough with this person saying this person is this. We're all American. We all have the objective to become the best nation in the world. Why? Because we truly are the last bastion of freedom. If we fall, it is over for mankind. There's so many bad, I want to say it really bad, but I won't because, they're bad, okay? It is hard to be good in a world filled with bad, you know what? And that's the way it goes. That's the way it goes. So either we have this power and we are able because of who we are, because of our foundation. Again, this year is the 250th anniversary of the greatest nation in the history of mankind, the great Rousseau thought of us and what we could become. Our founding fathers. Think about it. These were
Physics. If we figured something out, then Russia.
simple relation. Time is on the order of one of one divided.
It said people should not mess with America. People really understand
time.
What do you think?
100%, brother. As a matter of fact, this is what weapons of time speak to. The whole idea, it all starts with a very simple relation. Time is on the order of one divided by frequency. It comes directly from Heisenberg's uncertainty principle. If you can, please to your followers give, I think it's called The Ancient Pathways by Evan Howell. He's a friend also of our brother, Dave Rossi, and his name, again, Evan Howell. I had a recent pod with him on weapons of time. Glory be to Enki, as in the Sumerian Anunnaki. You should always bring in some mythology so you keep them guessing. But put it this way, brother, with weapons of time, it is as if, imagine winning all wars even before these wars are fought. That is the power of weapons of time.
You think that's possible?
We are the United States of America, brother. And as you well know, they can say whatever they want about us. They can call us all kind of names. They can call us fascists. They can call us all these things they want to call us. The bottom line is they are, again, I almost slipped. They are afraid of us. And fear is for ... slaves. I'll just leave it there.
Do you think it's right for us to do what we're doing? I mean, if my perspective, geopolitical take is that we're using this weaponry, this advantage that we have, and leveraging it to expand our empire, for lack of a better term. I mean, you've got Venezuela has fallen. Iran, we could probably take out anytime we want. Same with Cuba. And I'd say if that happens, don't be surprised. Greenland, we're just going to take Greenland from the Europe. And who knows? I'm even throwing out there, maybe we'll just take Canada and assimilate Canada. What do you think? Do you think this is appropriate? Do you think this is ethical?
Again, as a private citizen, look at the continent. Imagine being Fortress America. Some people will call it the American Empire. Whatever you want to call it, is still supreme among all other nations right now. So my opinion is this: either be with us or ...
I'm with you. I'm trying to keep neutral, but I can't pretend like it. I'm a huge America first kind of guy. And I'm actually seeing the shift in the political realms. And this is the reason why I started talking about politics. And people wonder, Ashton, why are you talking about politics? You can't disconnect.
Not stand. Remember that great man that once said, a house
merging with this fusion 2018.
And that's why you could hear a pin drop in the auditorium when I asked that question to Lockheed Martin.
Yeah.
Shit, Dr.
So what do
McGuire never
you,
got back to me.
because aren't you speaking to something, I mean, what we're talking about here
Because
is that
all the spice effect stuff is in the wide world, brother. It's in the wide world. And that is the power. This way, brother, with weapons of time, it is.
What do you think?
100%, brother. As a matter of fact, this is what weapons of time speak to. The whole idea, it all starts with a very simple relation. Time is on the order of one divided by frequency. It comes directly from Heisenberg's uncertainty principle. If you can, please to your followers give, I think it's called The Ancient Pathways by Evan Howell. He's a friend.
Who knows? I'm even throwing out there, maybe we'll just take Canada and assimilate Canada. What do you think? Do you think this is appropriate? Do you think this is ethical?
Again, and field, temporal weapons, weapons of time, which would greatly disrupt the arsenals of nations. Imagine the ability to win all wars, even before those wars are fought. Imagine the ability to win all wars, even before those wars are fought. Please take a look at Evan Howell's The Ancient Pathway. There's a certain episode with me that he has called Weapons of Time, Glory Be to Enki, mentioning the Sumerian deity brother of Enlil. It's very interesting. This is nothing new. I believe these existed at one point in time. They were called the Tablets of Destiny. And the great gods used them in a certain cosmic war. I know right now it's going off tangent, but trust me, you got to get Dr. Joseph Farrell on to truly understand the nature of plasma. It's a very, that would be an incredible quad. Have you, me, him, and Dave Rossi on. That quad would be amazing. And convince him that we're not here to in any way disparage his theories. No, not at all. The physics that we're talking about talks to them. This man, you have to read this book called Secrets of the Unified Field. This is no regular mind. This man should have been a physicist. Anyway, leave it there.
I agree. I hope he's out there, and I hope he sees this. And I would say that it'll happen eventually. I tell people that, and people wonder, like, how do you know it's going to happen? Because I know those videos are real. I know the physics is real, and so it's just a matter of time. We're just in a situation right now where we're ahead of the game. We're just really, really, really far ahead of the game. Maybe decades, and we're hoping that we're slowly getting closer to that goal. I said, and I think we both said, people asked me a long time ago, they said, Ashton, how are you going to get disclosure? What's the next thing? What do we do? Well, you've been watching it. The reason why I'm interviewing people like Salvatore Pais here and researching all these scientific papers is this is what disclosure is. It's about educating people. It's about getting them more knowledgeable so that it doesn't seem absolutely ridiculous when we start talking about plasma orbs and concepts like teleportation.
I work for the United States Navy. My name is Salvatore. Meter square. How? How is that possible? It is. Check out my paper on the plasma compression fusion device, IEEE Transactional Plasma Science, published 2019. The key here is resonance, energy amplification by a certain, let's call it resonance condition. And you will see, look carefully at equations 7, 8, and 9. I still remember the chief editor asked me after seeing that paper, did you have a weapon system in mind when you wrote this? She was a very intelligent lady. Anyway, let me just say now, because it's important, the way everything starts simple. I believe I call it let's call it the Bayes doctrine. Namely, simple is good. Remember, there's an energy. It all starts from Heisenberg uncertainty principle. Remember, there's an energy formalism to it. Delta E, delta T is on the order of h bar being the reduced Planck constant. Well, if delta E, again, Planck energy is on the order of h bar omega, where that is the frequency of vibration within the quantum vacuum, then you get something basically from differential calculus, simple. Time is on the order of 1 divided by frequency. Well, if you take by the chain rule, if you do a little mathematics using the chain rule on it, you get minus delta t is on the order of, say, a dimensionless constant, let's call it tau sub s, times delta omega divided by omega squared, where omega could be the frequency either of actual spin and or vibration. I prefer vibration. It is easier to work with vibration physically, at least from an engineering perspective. Now, at this point in time, remember, this minus delta t is on the order of tau sub s times delta omega divided by omega squared. All right? Now, remember the space-time metric. Under certain conditions, you can write the space-time metric as delta s. It's on the order of minus c delta t, where c is the speed of light. This minus delta t, do you see? Dimensionless constant, let's call it tau sub s, times delta omega divided by omega squared, where omega could be the frequency either of actual spin and or vibration. I prefer vibration. It is easier to work with vibration physically, at least from an engineering perspective. Now, I believe that it may be possible to design, develop, and field weapons of time, which would be highly disruptive to the arsenals of nations. Imagine the ability to win all wars even before these wars are fought. Furthermore, based on the space-time metric formalism, simple. Delta S is on the order of minus c delta t. Again, that minus delta t, I've shown how it goes on the order of tau sub s times delta omega divided by omega squared. What if you could have a brigade of special forces disappearing here and almost instantaneously appearing here in the enemy domain? Imagine the element of extreme surprise coupled with ultimate speed. Imagine what that could. So, in other words, it may be possible that the design, development, and fielding of weapons of time could be the most innovative engineering feat in quite a while. And according to our Secretary of War, Pete Hegseth, victory belongs to those who embrace real innovation. Well, gentlemen and ladies, followers of Chris Leto, there is nothing more innovative than the design, development, and fielding of weapons of time. All right, Chris, please take it. Any questions you have?
So, how did you come to this conclusion, Sal? How did you? Was it just theoretical through finding these relationships in equations, or do you have deeper background?
Believe it or not, completely. Again, I go by what I call the Pais doctrine. The whole idea started from, I noticed from Heisenberg's uncertainty principle, this idea of time is on the order of 1 divided by frequency. It all started with that. I took just simple chain rule on it, and I saw this minus delta t. So it gave me the idea, what if, just like the great Dirac, remember Dirac believed in not only the beauty of mathematics, but the physicality of mathematics. What if indeed this minus delta t spoke directly to a reverse temporal excursion? So in other words, under certain conditions, it may be possible to go back in time. Why? Once you rip apart the space-time continuum, you destroy the arrow of time, thus rendering Stephen Hawking's chronology protection conjecture null and void. It is now possible to have time travel to the past. Imagine the ability. But not only that, then I saw this thing in the space-time metric. How is it possible? Delta S is on the order of minus C delta T. That minus delta T spoke to me of this. What if we were to break the Schwinger limit? What if we could actually macroscopically teleport an entire Special Forces brigade almost instantaneously from point A in the enemy domain point C without ever traversing the medium B. What if there's a way? What if it speaks to something completely different? Something that quite possibly Kaluza Klein attests to the idea of a fifth dimension. Don't forget Ferris Williams, his idea of dynamic theory, from which he was able to derive the idea, the exact yield of the Castle Bravo thermonuclear tests. He was able to show why that yield was what it was, why it was so much amplified, almost 2.5 times higher than expected. And not because of the lithium-7. Anyway.
So this kind of reminds me of the original Pais effect.
His idea of dynamic theory, from which he was able to derive the idea, the exact yield of the Castle Bravo thermonuclear tests. He was able to show why that yield was what it was, why it was so much amplified, almost 2.5 times higher than expected.
Oak Shannon of the Wilson Memo mentioned the work of Ferris Williams of Los Alamos National Laboratory in his recent first-ever interview. Ferris Williams has a unified field theory that predicts compact fusion, electrogravitics, faster than light travel, and that the Big Bang never happened. I watched the interview that was just live-streamed today. If you are not familiar with the Wilson Memo, it's the alleged transcription by Dr. Eric Davis of a conversation with Admiral Wilson, in which Wilson allegedly admits there is a reverse engineering program for off-world craft, but he couldn't access it. Oak Shannon is mentioned in the memo and has spoken publicly about it for the first time. The interview is in the show notes. Most of you will gloss over one of the most important details of the discussion, and that is Shannon's claim that Dr. Ferris Williams was working on some new theories that he thinks others may have secretly tested and developed. This piqued my interest, so I started searching for Williams's work, and it's a bombshell of information. Williams' work is well documented and much is even published in peer review. He did most of it at Los Alamos and New Mexico Tech University. It's called the dynamic theory, and it states that mass density is the fifth dimension. He claims it forms the equations for all other theories, but also introduces new predictions, some of which can be interpreted as already have been verified. Researching this properly is going to take quite a long time, as I just spent 4 hours compiling all this information and skimming it. This post is just a preliminary report. For many years now, the ultimate quest in physics has been the unification of Einstein's general relativity with quantum mechanics. Dr. Williams discovered that both these theories can, in fact, be derived from the laws of thermodynamics. The resulting theory eliminates the singularity problems of the conventional theories and makes a variety of intriguing predictions. In his theory, Williams finds the equations of thermodynamics have, Dr. Williams discovered that both the otherwise distinct equations of physics, be derived Newton's mechanics, classical thermodynamics, Einstein's special relativity, Einstein's general relativity, quantum mechanics, quantum electrodynamics, the nuclear strong force and weak force, gravitational force, and a deeper view of cosmic redshift. Because his work fills gaps in the standard model of physics from the unexpected starting point of the laws of thermodynamics, he has been blocked from publication in the premier science journals of our day. He has 2 books published on his work. They can be found in the show notes. I even found one of his books online for free and have shared it in the show notes. Williams states, in summary, the book presents detailed derivations of numerous applications of the classical thermodynamic laws with the result that phenomena currently covered by Newtonian, relativistic and quantum mechanics are predicted by these three laws. This is a significant reduction of the number of required fundamental assumptions in the description of these phenomena. Additionally, many new phenomena are predicted that lead to new views of the universe. End quote. The first thing I found in my research was a DOE Office of Scientific and Technical Information document published in 2015 titled Memorial and Thoughts of a Man with Great Ideas, Ferris Williams. Before I dig into the document, I want to point out who the authors are. One is Oak Shannon, who worked with Ferris Williams at Los Alamos Labs. Another is from Sandia Labs. Then there's Paul Murad of Morningstar, who states in his LinkedIn profile that he has over 25 years of public service as a senior technology analyst for the Department of Defense, looking at foreign advanced and game-changing technology, as well as defining future U.S. satellite systems for the next 20 years. David Mathis of Spacelines has a SPI profile that states, ongoing optical research involves Dirac, Majorna and Weyl models of the electron internals, Zitterbewegung, Bohmian quantum mechanics, and transactional hypothesis. So what does the document about Williams by these authors say? Here is a quote from the abstract. By applying simplifying or restrictive assumptions to the main body of the theory, Ferris shows that the major fields of physics are contained within the extensions of this theory. In these extensions, new field quantities appear to become important for systems and technical disciplines. Thus, the dynamic theory that he created would unify the various branches of physics into one theoretical structure. Only the future can tell what will be the impact of Ferris dynamic theory contributions, and how engineers and scientists can gain and find new insights. End quote. It then goes on to explain his theory and work in more detail. It mentions a popcorn program, or a popcorn project, that was apparently an embarrassment to the Navy, where Williams reportedly proved that a bunch of nuclear weapons were not being stored properly and a catastrophic event could potentially, the various branches obscure offered to fund Williams' research.